Okay students, class 12th mathematics Cbse. Today we will discuss the different properties of the inverse trigonometric functions. Okay, and we will use these trigonometric functions in solving the trigonometric equations. Okay, so first of all, sine inverse x is equals to x. Sine inverse x is equals to x, where x lies in closed interval minus 1 and 1. Okay, and then second property, that is cos inverse x. This is also equals to x, but here x lies in closed interval minus 1 and 1. Then tan inverse x, that is also equals to x. Here x belongs to the set of real number. And cot inverse x, this is equals to x. X belongs to the set of real number. Then sec inverse x is equals to x. X belongs to r minus open interval minus 1 1. Then lastly, cosec inverse x equals to x, and here x again belongs to r minus 1 1. Okay, so these are the first type of properties of inverse trigonometric functions. Okay, then after second type of properties of inverse trigonometric functions are sine inverse of sine x. This is also equals to x, but here x belongs to minus pi by 2 and pi by 2. Okay, then cos of x equals to x, and x belongs to 0 to pi. Then tan of x is equals to x, and x belongs to open interval minus pi by 2 and pi by 2. Okay, then it is term of cot of x, and this is also equals to x, but x belongs to open interval 0 pi. Okay, then sec inverse of sec x, and this is equals to x, and x belongs to r minus x belongs to 0 pi, closed interval 0 pi minus pi by 2. Okay, and lastly cosec inverse of cosec x, and this is equals to x, and here x belongs to closed interval minus pi by 2 minus 0. Okay, so these are two types of properties of the inverse trigonometric functions. Now the third type of the properties of inverse trigonometric functions are sine inverse 1 upon x. Sine inverse 1 upon x, let this is equals to theta. So sine theta is equals to 1 upon x, or x is equals to 1 upon sine theta or cosec theta. Okay, so theta is equals to cosec inverse x. Okay, now let equation number 1 and equation number c. Observe the equation number first and equation number second. Sine inverse 1 upon x equals to theta, and theta equals to cosec inverse x. So equating the equation number 1 and 2, we will have sine inverse 1 upon x is equals to cosec inverse x. Okay, this is first property of third type of the property. Sine inverse 1 upon x is equals to cosec inverse x. Similarly, we can write down cos inverse 1 upon x is equals to sec inverse x, and tan inverse 1 upon x is equals to cot inverse x. Okay, and inversely we can write down cosec inverse 1 upon x is equals to sin inverse x, and sec inverse 1 upon x equals to cos inverse x, and lastly tan inverse 1 upon x equals to cot inverse x. Okay, so these are some of the property comes under the category third. Okay, now let us have the category number 4 of the properties of inverse trigonometric functions. Okay, so we have sine. This is fourth type of property. Sine pi by 2 minus theta is equals to sine pi by 2 minus theta is equals to cos of theta. Okay. Now let sine inverse x is equals to y. Okay. Then x is equals to sine y. Okay. Now this implies x equals to sine y, and sine y equals to cos pi by 2 minus y. Sine theta is equals to cos pi by 2 minus theta. Okay, so cos inverse x. Now cos inverse x is equals to pi by 2 minus y. Cos inverse x is equals to pi by 2 minus y, and y is equals to sin inverse x. So it is sin inverse x. Okay, transferring sin inverse x to the left hand side. So sin inverse x plus cos inverse x is equals to pi by 2. Okay, so this is one type of property of inverse trigonometric. Similarly, we can write down that tan inverse x plus cot inverse x is equals to pi by 2, and sec inverse x plus cosec inverse x is equals to pi by 2. Okay, so the next type of property, that is fifth type of properties of inverse trigonometric functions. Okay, fifth type of properties of inverse trigonometric functions, that is sin inverse minus x. Sin inverse minus x is equals to. Okay, first of all let sin inverse minus x is equals to y. Sin inverse minus x is equals to y, then minus x is equals to sin y. Okay, and then x is equals to minus sin y, and x is equals to sin minus y, and minus sin theta is equals to sin minus theta. Okay, using this trigonometric identity here, we will have x equals to sin minus y. So sin inverse x is equals to minus y. Okay, now putting the value of y is equals to sin inverse minus x. So sin inverse x is equals to minus sin inverse minus x. Okay, or sin inverse minus x is equals to minus sin inverse x. Similarly, we can write down as tan inverse minus x is equals to minus tan inverse x, and cosec inverse minus x is equals to minus cosec inverse x. Okay, and let cos inverse minus x is equals to y. Then minus x is equals to cos inverse y, or x is equals to minus cos inverse y, or x is equals to cos pi minus y. Cos pi minus theta equals to minus cos theta. So cos inverse x is equals to pi minus y, or cos inverse y is equals to cos inverse minus x, cos inverse minus x, or we can write down as cos inverse minus x is equals to pi minus cos inverse x. Okay, so cos inverse minus x equals to pi minus cos inverse x. Similarly we can write down cot inverse minus x equals to pi minus cot inverse x, and sec inverse minus x equals to pi minus sec inverse x. Okay, so these are also the properties of inverse trigonometric. So student, now last type of property, some properties of the inverse trigonometric functions are sin inverse x plus sin inverse y is equals to sin inverse x under root 1 minus y square plus y under root 1 minus x square, and then sin inverse x minus sin inverse y is equals to sin inverse x under root 1 minus y square minus y under root 1 minus x square, and then cos inverse x plus cos inverse y is equals to cos inverse xy minus under root 1 minus x square under root 1 minus y square, and cos inverse x minus cos inverse y is equals to cos inverse xy plus under root 1 minus x square under root 1 minus y square, and lastly tan inverse x plus tan inverse y is equals to tan inverse x plus tan inverse y equals to tan inverse x plus y upon 1 minus xy, and tan inverse x minus tan inverse y is equals to tan inverse x minus y upon 1 plus xy. Okay, so these are some of the properties of the inverse trigonometric functions. We will have the proof of sin inverse x plus sin inverse y is equals to sin inverse x under root 1 minus y square plus y under root 1 minus x square. Okay, we know that sin of a plus b is equals to sin of a plus b equals to sin of a cos of b plus cos of a sin of b. Okay, so a plus b is equals to sin inverse sin a cos b plus cos a sin b. Okay, here let a is equals to sin inverse x, then a is equals to sin inverse x, then sin a is equals to x, and cos a is equals to under root 1 minus sin square a. So cos a is equals to under root 1 minus x square. Again let b is equals to sin inverse y. So sin b is equals to y, then cos b equals to under root 1 minus sin square b. So cos b is equals to under root 1 minus y square. Okay, so now we have to put the value of a, b, cos a and cos b, sin a and sin b. Okay, in equation number first. Then we have from equation first a means sin inverse x plus b means sin inverse y equals to sin inverse sin a means x under root cos b means under root 1 minus y square plus cos a means under root 1 minus x square, and sin b means y, so y. Okay, so sin inverse x plus sin inverse y is equals to sin inverse x under root 1 minus y square plus y under root 1 minus x square. Okay, so this is the proof of sin inverse x plus sin inverse y. Now we can have the proof of other trigonometric identities like this. Thank you.